is actually the continuation of the presentation from Tuesday, and it was originally the second part of that. So, as such, of course, it has exactly the same like the Tuesday presentation. So, in total, we are very proud that everything is an object. Classes are objects, methods are objects, but variables are variables real objects. So, for example, if you look at class variables, we have on all classes we have an API which is called class1name. And now you would think that this returns, of course, the variable object of that, defines what this variable is. But that's actually not true. If you say small image class1name compiler class, it returns the value of that class variable. A bit similar, but already a bit nicer is if you have a global, there is actually an object which is called a binding, which models this variable in some form. So we can say object binding, and this is actually in Pharo 4 or 3, before we introduced our new stuff, was an association, which is already nice, so it's more than a string, but nevertheless, it's not a variable, it's an association. So the question is, why are these things not objects in our system? The first thing that we can look at and see if we can actually make them into objects are the globals and class variables, because they are already associations, so this should be relatively easy to do. So what we did there is that we actually added a subclass to association called the literal variable, because that's what the VM knows. So all class variables, bool variables, and globals are all the same kind of variable, the literal variable. So we made a subclass of that. And then this literal has subclasses itself that model the variables that we have in the system. So we have a global variable for the globals like object, and we have class variable for all the class variables in the system. And in addition, so that we can work with that, we need to enhance the API. So for one, we need to have a message on our classes so that we can, for example, ask the class for a specific class variable. Or we can ask for the value of the variable with a message. In addition, for the globals, as we just kind of co-opted the binding mechanism, we can just use the object binder, so the binding mechanism. I'll show you that in the running system. So if we go to Pharo, now if we say let's want to give a class variable and compiler class, it will actually return something which is a variable. So I let the printer for compiler is the same like it used to be for class. It might change in the future. But if you ask it for its class, you now get back this is a class variable. And if you say object, can you repeat that? Cannot hear it. If we say object, binding, we get back global variable. So that's nice. But, so now we have objects that are specifically describing our globals, class variables, and bool dictionaries, which are class variables. What is now missing is actually only an API on this object themselves. And for globals it's easy, it's just we have read, which gives me back the content of that variable. In this case, it returns an object. Or, and I will not do that now because it will crash my image. You can write to the global variable. This will store the value. So that's easy. It's not a lot of change code actually, if you think about it. It's just a couple of subclasses, some change in the system that they are created correctly. And we have now, instead of these kind of strange bindings, we now have real variables. We can now assign this global variable, so we can do stuff. And we have, of course, so that you will have to write this get the global out of the class and then operate on it. We do have a lot of helper methods to get the value to store directly on the class. And we have compatibility methods. So we kept all the existing methods so that you do not have to change your code yet. Maybe later. But right now everything is compatible. And so we did it now for the global variables, class variables, group variables. Can we do the same for instance variables? So you might think, in our system we have this instance variables method. Let's copy it wrong. You might think, for sure, this is not everything an object. If I say point instance variables, I will get a connection with the two instance variables x and y, for sure. But if you do that, you get actually back an array with two strings.
Can I make the font bigger?
Huh?
Can I make the font bigger?
The font bigger.
Big font bigger? Yes. Hello?
Yeah.
So we get back strings, and as we get back strings, everything actually in our API operates on strings. So if we want to access a variable, we just say, give me the instance variable name x. So we say instance variable instance name x, and you get the variable. Another, and if you want to change it, you have instance name input. So it's not actually an object here, instance variable. It's just a string. So the question is, why is that just a string? For one, of course, if you want to now use objects for modeling this, you need to add objects to the system. So if you want to have an object modeling every instance variable will have an object, and that means that you have some more objects in the system. And in the original design of it was of course completely impossible. If you can only have 64,000 objects, you will not do that. But today, I think there is no problem of doing this. We have memory to have that another 8,000 objects, who cares? So we can actually model much nicer. So what was done is that we added something which we call slots. The reason here again is that we want to have an API that is orthogonal to the old ones. We do not want that suddenly methods that used to operate on strings operate on objects, and everyone has to change all the code at once. So the naming is taken in a way that it's explicitly orthogonal to the old naming for compatibility. And so the name that we have is slot. So you can, for example, see if you have point, you can ask it for slots, and it will return you will return you two array with two objects, and the printing is done in a way that you actually, so this is the creation method already of a slot. So if you evaluate that, you get back a slot object. So that means this is a slot, an instance variable slot, which is named x, and an instance variable slot named y. Which means, from that you can see, okay, so what used to be all instance variables, these are all instance variable slots. That means, how many are there? Ask, size, 8,880. So we have 8,880 instance variables in the system. If you now want to read, if you want to get a specific slot out of a class, we say point, for example, slot named x, and it will return you a slot. And if you want to read this slot, of course, the slot object has an API to read data, but of course, as it's a definition of a class and not of an object, it reads from an object. It's just a definition of how do I read the slot named X, or this slot, from an object. That means you always need to specify an object from which you want to read. So in this, if you say 3, it will return. And if you say write, then write to an object, it will change that object, but return the Opal, so it doesn't make sense to print it. So this is how to use slots reflectively to change an object. Of course, you are not supposed to always give me slots, then you will read too much work, so that's why we have a lot of helper methods which say read the slot named X directly from the class, and we have the Opal Compatibility API so that it stays compatible with the old system completely. So this is nice, and the question is now, what can we do with that? Is it worth to invest 8,880 objects into this? And the first thing, which is related to the talk of last week, is imagine you want to hook into variable access. With the meta-link system on AST, what you can do is you can get all the AST nodes that you are interested in and put a meta-link on it. So for example, we have a couple of helper methods that make this easy. So if you want to know point, assignment nodes. And it will give us back all assignment nodes from the class point. And the inspector has this nice connection to the source code. You can now actually go through and see which ones these are. Kind of fun. And you can put a meta link on all these assignment nodes that you would do variable access. Perfectly doable. This is how we did it in these meta-link systems in the past. But now with this idea that we have an object describing this the variable of two variables of points, the two instance variables, we actually can directly put a meta-link on this entity. So we can directly say one slot named X, here is the meta-link, and we read and write to that variable should follow that link. Which is, so this is not yet finished in Pharo 5, so there's only a demo for simply 4 links using variable generation, and not really, so it needs a bit of work, but it will come. And this allows you to be more smaller model than you think about it. And what is nice is that this means that you will be able to put a breakpoint on the variable definition. So in the in the browser where you have an instance variable definition, you can say on the next read of this, please hide. Or the next write of it. Very nice. So this is the first use, and one can still argue about 8,000 objects or that. So, but there's more. We can actually do more with this. And for that, we need to go back to the compiler that we now have in the system. If you look into this stream of data to the visitors, then we have this one phase, the semantic analysis, which actually looks at the AST and the variables that are defined in the AST. So there's an instance variable definition, and then there's an assignment to instance variable read, and it actually analyzes this A. What is that? Is that instance variable? Is that a read? Is that a write? And that means that we annotate the AST with variable information. And this in turn means that the compiler at that point knows the slot that this variable is about. And this means that in the next phase, if you go into code generation, you can actually defer code generation to this one object. So the compiler does not need to know it itself. It can just say, I found a slot, or I found a global. I don't know what to do. The global should tell me how to generate code for itself. I don't care. And this means that we actually have on the hierarchy of our globals and slots, we actually have a compiler interface, where we know that when we generate code, the compiler will come here and tell us what to create code. As a default code that it will generate, so if we have the superclass, it does the reflective read and write that we saw. So it will just emit bytecode that does the reflective access. So in this case here, you see it, you know that, okay, it's named emit value, that's the method the compiler will call, and it will give you method builder to this method. And the method builder will just use push literal variable with an association. The reason is that this guarantees that then this is a method that looks kind of normal. If you would say push literal and then the object then looks to the string. So we do that one direction. And then we send the read that we saw before. So just a reflective read. And the reflective write is a bit more difficult because we need to have the random thing on the stack. So we need to first store it in 10, push it, the other one then pushes, and then we use the write on this one. So we use the slot object to store and read data on the compiler. But of course, that would be really slow. So the subclasses, and for the globals, the class variable and the global variable subclasses, they actually override this method and just use the same method that was used originally. So the store into literal variable, for example, for the store of class variable. And that means that the bytecode that our compiler generates for the default globals and for the default slots is exactly the same as before. So that means you do not pay anything in performance. Yet, yeah, so for slots the same, so the slot superclass uses reflective read and write, and the instance level slots overrides that method so to do the instance to use the bytecode that makes it fast. What does that mean? So to summarize, we have now slots and globals as instances of the class. The compiler delegates code generation of these objects. And of course, as this small talk, this now means that we are free to make subclasses of these things. So we can now take both slot and global, and we can make our own. And as we can override the code generation method, we can actually change what happens when the variable is read or when it's written. One thing that we need for that to work for real is we need to have a new class template. Because in the current class template, when we create a Smalltalk class, you specify explicitly this has instance variables and it's a string of instances with the space in it. Which is not enough because we now want to define our own objects and we need to be able to specify them in the class template. So that means that we change the class template a little bit. Right now it uses slots. And sometimes I think we should go back to instance variables column to be backward compatible and more on the mindset of the Smalltalk programmer. So I think I will do that. It looks better with the class variables the second. So and the only difference is that instead of a string of a collection of it's just a string. We now put an array. Evaluate array, and we have a shorthand right for normal instance variables, so that we do not have to specify the complete slot because we know that in most cases we normal instance variables. So we have just symbol x to symbol, and this will just create an instance variable slot, the default one. But if you want to make your own kind of slot, you can do that. So we, for example, implemented weak slot, and weak slot hides away all this complexity of using weak variables. If you want to use a weak reference in this context, the only thing you have is you can make your own weak subclass, or you can use an array of size 1. It's always annoying. I need to use accessors, or I need to initialize the array. There's a lot of complexity. And here we hide that all the way. So the weak slot implements weak reference, and as you would do that with an array of size 1, but you don't see it at all. And you specify that as. Yeah. And I want to show, I think the weak slot is a nice example to show it. In system. So for one, we should look at the definition. So the weak slot emits bytecode which does exactly what you would do when you would write this byte yourself and so on. So maybe we look at the reflective one there. It's kind of clear. So we first read from the object like we would normally, super, and then you just get the instance. You just do N1 because it's an array of size 1. Okay.
Increase the size.
Why is this now not changed? I think we have a bug actually in the
No, you change it only some fonts, not all of them.
No, there is a bug in rubric. There is a bug in rubric that it doesn't take the stuff into account. So yeah, rubric has a bug that it does not take this into account. How does it again work with zooming into the bank?
Control and
Right, control.
Command plus.
No, the zoom of item.
You can copy paste it in the workspace.
I will copy it in the workspace. So writing works the same. So we just read this object, which is the array of size 1, and we set this. And to make it fast, we have code generation with that generates bytecode for this, so that we don't need to use the reflectivity, so we don't actually need to really look at it. And I just want to make a class with a weak slot, so let's call it my class. Just need to do the settings. We have very hidden something which is called class template with slots, and we enable this. Then you actually get a new template, and we do not see it because it's too small. But this just means we will just make a variable named x, which is a weak slot. We accept. This, and then I go to the playground so that you can see something. And we can actually say my class new. And then you see that it actually has, for the environment, this is hidden away completely. So for you, this is just a normal object with one scope, which is x, and it's just shown for it. But behind that, we have not yet extended the field inspector to show that it actually uses a hidden base slot, which is an array, which is our function. So these are the possibilities that you have. So you can actually define a subclass for a variable and change the meaning of read and write. And the examples that we have for that. So I didn't show the simple slot but the weak slot because it's good enough. So we have weak slot which allows you to use weak references in a way that you can explain it in Ruby in the first and you will explain instance variables. Very nice. Other examples that we did is, for example, property slot. So property slot gathers all property slots of the hierarchy and stores them into one dictionary, which means that this is nice for cases where you have a lot of variables that are mostly not used. In morphing, for example, this is the case in morph. Morph has a morph extension, so morph is 4 instances rather than the morph extension has like 10, and then there's additional property in the dictionary because that was not even enough. And so we cannot order that directly in the class. That's nice. Another thing that we can do, which I do this here, is we have right now the problem we can only have 256 instance variables, and that is especially annoying when you use splitting parser. This will be fixed with the next bytecode set and the new version of Coq that will come out. But if you want a solution now, what you can do is you can make a slot which actually stores into an array. So just as one iteration into an array, hidden away completely, and you can do an indefinite amount of instance variables. It's relatively fast speed because the only thing you do is add and put on an array. Another example is a Boolean slot. This one gathers all Boolean slots of the hierarchy and stores the Boolean into one integer. And as we have automatic overflow, this is kind of fun that you can actually do 0 bit at 5,000 and it will return you a large positive integer which has 1 bit set and number 5,000. And that means it actually means an indefinite amount of Boolean Boolean slots mapped into one instance variable which will overflow into the large integer when needed. It will get bigger than if you need more than one Boolean slot. So these are the things that are working right now. There are some bugs left, so especially interaction like adding a slot and then changing to another one, or having multiple slots over the hierarchy and removing one. There are some bugs left that we need to fix, but the simple examples are already working. It's quite nice. The roadmap is that actually we started to add these things already in Pharo 3, but it was completely hidden. It was just inside the system, and we started to add a compiler which is needed for that, because without a compiler that is extensible, you couldn't do this at all. Pharo 4 actually has a deeper support for slots, so if I remember correctly, I finished the Monticello support at Pharo 4. Yes. So that means you can save these things, and they are saved at Monticello, and they're actually saved in a way that this package is still loadable on old version Pharo and even on other systems, because it is stored in a string. So that means if you load this class definition on another small job, it will create an instance rather than miss the name of the slot definition, which is of course not valid as a name, but it allows you to load the code, and if you want to then change and implement this all yourself, like a weak slot, you can easily, you can load the code, that's not lost. That's nice. Now, Pharo 5, we continue to work on this, to fix all the remaining bugs and to add some examples, and we will finally remove the old compiler, which is very important for being able to clean up more of the system. And we want to finish the first version of both slots and reflectivity in a way that you can put links on slots, that you can make your own slot subclasses, that you can use them, but we will not use it in the system at all. So we will not start to use slots for something, because this needs some, we need to learn how to use it, and we don't want to do that in the system. So that's actually what will happen in Pharo 6. So for Pharo 6, we want to have a useful library of slots ready. For example, slots with default value, slots that announce that they have been changed, Boolean slot, bit slot, the slot that allows you to have an indefinite size of number of instance variables, things like that. And people in Pharo 6 will start to use slot for real. So already the prototype of block, of the widget set on top of block, of Pharo, even higher level, the one that is used for GT Inspector. This one already, the prototype uses slots for change notification. It was kind of funny because I put the slots in and explained on the database how to use them, and a couple of weeks later, days later, I wanted to change something, and I thought, oh yeah, it's easy to change other subclasses of slots, and whatever. And then I realized, there is a prototype in the GT Inspector package that actually uses all of this. And wow, that was a lot of fun. But it was then removed because we found that we should not do that, right? But it will come. So very nice. And then in the even farther future, one thing that I'm wondering is, can't we actually model bit patterns better? So if you look at this, we have when you interact with the system, you always see structs where you have a couple of bits here that encode an integer and something here that encode something else. And can't we have some kind of graphical thing where you say A, B, B, and C, whatever, until you reach your size of the object, and then bind individual slots to them. You say, okay, the slot that I marked as A in my pattern, this is an integer with a range of 0 to whatever. Or this is supposed to be a character. Or maybe we could even map it to be completely a DSL that describes C structs and have something that models that. And then to have the slots that then you can just assign to something, and behind the scene it actually does the bit shifts and stuff and stores into this low-level data. So that's something that I want to explore a bit, which would mean that this is on the level of the layout, which is something I didn't talk about at all, because we have first-class layouts of classes too. So instead of having this number that describes the layout, we have objects, and this would be an extension of it. And related to that is, how can we make array-like things more like slots? And can't I have an array-like subclass in a way that I can hook into add and output easily? Would be, I don't know, would be interesting to look at. So this is the work of a lot of people, and there were a couple of prototypes and a lot of playing around. And because it is a deep change in the system.